Hey guys, we're back with the notes for 10.3. I know a lot of you were not a fan of Unit 7 memorizing all those exponent values, but if you remember your powers, or if you have that written down somewhere as a way to remember, this is the moment where it's going to come back to help you, okay? So we're going to be talking about how to solve exponential equations when you have like bases, okay? So if we don't have like bases, we're going to force that to happen so that we can solve, okay? All right, remember that b is called our base, x is our power or our exponent, and your goal, let me zoom in, your goal is going to be trying to write a base with an exponent is equal to the same base with a different exponent, because if we know that, then we can say the exponents are equal, x equals y, okay? Let me give you a very, very, very basic explanation of that. If I was to show you, this is the first problem, 3 to the x is equal to 3 squared. They have the same base already. The 3's are the same, so that means my exponents must be the same. X equals 2 and we're done. There's no solving, nothing going on with that, okay? Second problem. I don't have the same base, but I can make it the same base. 2 to the x equals 8. We know that 8 is the same as 2 to the third power. Now that the 2's are the same, I can say the exponents match. X equals 3. No solving. That's it. Very basic, okay? Let's do the same thing here so I can kind of show you where it's coming from. I'll zoom out in just a second. All right, 4 raised to the 3x plus 1 is equal to 16 raised to the x minus 1. Notice when I change it, I do not change where the x minus 1 is. He's on the outside of the 16. All I do is I wrap the 16 in parentheses and change him to a 4 squared. Because when I write my exponents down, I have to remember the exponent rule of multiplication. A power to a power, or double exponents in and outside of parentheses, have to multiply. That's how I end up with this part right here. It's not 2x minus 1. It's going to have to distribute like 2x minus 2. Okay? All right, so now that we got a basic understanding, I'm going to go ahead and show you one more thing. On number 5, I need you to understand that you can never take a base and change it to a negative number, okay? I can't like raise it to a -1 and make it a -5. If you cannot make them have the same base, that is something we will solve a different way later, but in this case, you would not solve it on this problem. You would just say, I can't, okay? I do not expect you to give me a value for x. All right. 1 and 2 are already solved, so if you need to pause that for just a second, go ahead and do so now. We're actually going to solve number 4 next. Perfect. So on number 4, I do have it already started. I have the equations already, or the exponents already set equal. Let's look at solving this guy. I do have to distribute, so 3x plus 1 is equal to 2x minus 2. If I put all my x's to the left, that means I'm subtracting 2 x's. That gives me 1x. If I move my 1 to the right-hand side, that means I'm subtracting 1, which would give me a -3. That is the end of my problem. My x is -3. Okay? All right, I'm going to jump back. I kind of zigzagged for you a little bit, but I'm actually going to jump back over to number 3 and 6 next. Okay? All right, so number 3, the way I like to write them is I start with the black, and I say who is as simple as they can go. 4 to the x, I can make a 16 out of a 4th power. So 4 to the x is not going to change. I am going to change, though, this 1 over 16. Okay? 1 over 16 is the same as saying 4 to the -2. The negative is what makes it a fraction. 4 squared is 16. So equals 4 to the -2. Then I'm going to take my exponents. And I'm going to set them equal. So in this case, my x is going to equal a -2. There's no work to solve on this one. It is what it is. Okay? All right, let's try number 3. Number 3, the 10 is already in his simple base. So 10 to the x plus 1 is not going to change. I'm actually going to change the 1 on this side. So 100 is 10 squared. So I'm going to wrap him in parentheses, 10 squared, and his exponent is going to stay on the outside. Because when I multiply these, I have to make sure that I'm keeping them separate. So 2 is going to be separate from the 3x, They're going to have to multiply. And I'm setting that equal to x plus 1. All right, so solving this out. 2 times 3 is 6x equals x plus 1. I'm going to move the x to the other side by subtracting it. That gives me 5x equals 1. Divide both sides by 5 gives me 1 over 5. Okay, we can keep them fractions. If you wanted to give me 0.2, that would be fine also. I wouldn't mark that wrong. Okay. All right, if you missed 1 through 6, you could pause it now and copy those. Otherwise, we're going to hit 7 and 10 next. All right, starting with 7. Number 7. I'm looking at these guys, and I noticed that 27 is not a power of 9. But 9 and 27 are both separately a power of 3. So I'm going to rewrite both of these. The 9 I'm going to make 3 squared. The 27 I'm going to make 3 to the third. I keep the exponents that they already had on the outside because when I put them together, I'm going to have to remember to multiply. All right, so we're doing 2 times 2 to the x, 2x, and 3 times x minus 1. Multiply that out gives me 4x equals 3x minus 3. I'm going to move the 3x to the other side, leaving me 1x equals negative 3, and that is my final answer. Okay. All right. I lied on doing number 10 next. We're going to do 8 next because I don't want to get into the equations until we're done with the single pieces. Okay. All right, so 5 is already as simplified as it can go. 1 over 25 can be written as a power of 5. So if I'm keeping 5 to the x minus 4, he's not changing. But this guy, 1 over 125, is actually 5 to the negative third power. The negative is what makes it the 1 over. The third power is saying 5 times 5 times 5, okay? Keeping your exponent, 4 minus 2x. Now that I have them with the same base, we're going to multiply. So I have x minus 4 is equal to a negative 3. Make sure you use your parentheses. 4 minus 2x. We're going to distribute this. So x minus 4 is equal to negative 12 plus 6x. I'm going to move my x's to the right by subtracting an x. That gives me 5x. I'm going to add the 12 to the left side, which is going to give me 8. And when I solve this out, my x is going to be 8 over 5 because I'm dividing both sides by 5. Okay. All right, one more like this. Let's look at 9, and then I'll zoom out so you can copy. All right, 4 looks like it would normally be simplified, but in this case, we're using the 2's. I'm actually going to have to change both of these. So 4 is going to be 2 squared with the x on the outside. 1/2 is going to be 2 to the negative 1 with the x minus 3 on the outside. Now, I can set the exponents equal. Make sure you're using parentheses. 2 times x and negative 1 times x minus 3. We can distribute that. 2x equals negative x plus 3. We're going to get that x to the other side by adding it. That gives me 3x. And if I divide both sides by 3, we get 1. I'm going to zoom out so you can see the top, guys. So we're doing problems 1 through 9 are already set. I'm going to explain on number 12 what we're doing for the rest of these. Okay? All right, on problem 12, let's look at this one. I looked at 3. I saw that he was basically already done. 3 is as simple as you can go. So 3 to the 4th didn't change. But when I looked at the 81 and 243, I realized that both of them could be written as 3 to a power. So I put 81 in parentheses and I changed it to 3 to the 4th. I put 243 in parentheses, made it 3 to the 5th. And then I wrote their exponents that they already had on the outside. Now, what did I do to get the blue equation? Well, we know that laws of exponents say if you have the same base and you have it in the numerator and denominator, you would subtract the exponents to simplify the answer. So for instance, if I had x to the 5th over x to the 3rd, we would subtract that to make x squared. Okay? That being said, I can say this the same way. 5 minus 3 equals 2. All I'm doing is worrying about the exponents only. Okay, so I took the top, kept the 4 separate, right? 4 distributes to 3n plus 2, and I subtracted away the 5 multiplied with the negative n, okay? I would highly, highly, highly encourage you write it out keeping parentheses so you don't lose any signs, okay? All right, that being said, now I can solve this problem. So I'm kind of going to solve it and move it a little bit to the right-hand side. So solving this out, we're going to go 12n plus 8, I'm distributing, plus 5n equals 4. I'm going to combine and move the 8 at the same time. So 12 and 5 together makes 17n. I'm going to subtract the 8 over, which gives me a negative 4. And when I solve this, I get negative 4 over 17 as my answer. Okay. All right. Now that we've seen kind of what the problem solving looks like, let's go backwards and let's look at 10 and 11. Okay. All right. So number 10, this 2 is as simple as he's going to get. So 2 to the x isn't changing. But I can rewrite 1 over 32. 32 is 2 to the 5th. So in this case, it would be 2 to the negative 5. He doesn't have an exponent on him right now, so I don't really need the parentheses. But I do know that 32 on the other side is going to be 2 to the 5th regular. All right, so let's go back and look at our rules for exponents, what we would normally do. If I said x to the 3rd times x to the 5th would make x to the 8th. Normally we would add up our exponents. So 3 plus 5 makes 8. We're going to do the same thing with our exponents in our problem. We're going to say x plus a negative 5 is equal to 5. Those are my exponents. I'm just adding them up because everybody has the same base. Solving for x, that means I'm going to add this 5 to the other side. And x is going to give me 10. So 2 to the 10th times 2 to the negative 5 would leave me with 2 to the 5th power. Okay? All right, let's try 11. 11. 16 is not simplified. 16 has 2 different options. You could take it all the way down to 2 to a power, or you could take it as 4 to a power, because either way, 64 will work. What you cannot use is an 8. Okay? So let me show you that one time. You are fine to do 2 to the 6th times 2 to the 4th. You don't have to write this down yet. 2 to the 4th. That problem would work. Or you could do 4 to the 3rd times 4 squared equals 4 squared. Either of these will give you the exact same problem because all you're doing is doubling all of the exponents. We're going to get rid of the bases in just a minute anyways. If it was me, I would probably use 4 as the base instead of 2 just because it makes my equation number smaller. Okay? If you wrote down 2's already across the top and you want to use that, that's fine. I'm going to use the 4's. Okay? All right, so in this problem, I am changing everybody because nobody was simplified. Now we're going to take all of our exponents and we're going to write out our equation. Remember that when we are multiplying here, that means we are adding up our exponents that are on the same side. So 3 plus 2 parentheses negative 3x equals 2 parentheses 3x minus 2. We're going to go ahead and distribute that. So 3 minus 6x, right? Positive 2 times negative 3 equals 6x minus 4. I'm going to add the 6x to the other side, giving me 12x. And I'm going to add the 4 to the other side, giving me 7. Your final answer is going to be 12 over 7. No, totally messed that up. I was right the first time. 7 over 12. You're dividing both sides by 12. My apologies. All right, I'm going to zoom out in case you need to copy anything. I know it's a little small for 10, 11, and 12. Go ahead and do that now. And then we'll talk about 13 and 14. I'm almost done. Okay, on 13, it says if 3 to the x is equal to 81. We should know that. You should know 3 to the 4th makes 81. So in this case, x is 4. and 5x minus y, so 5 times 4, minus y equals 23. So let's solve that. 5 times 4 is 20. Minus y equals 23. I'm going to move my y to the other side to make it positive. Subtract 23 gives me negative 3. So now I have x and y. It says then y equals, and you have your answer. Okay. All right, that was not super complicated. Just wanted to kind of show you how you can use that chain of reaction. Okay, so this one says if 2 to the x is equal to the square root of y. So let's go back and remember our exponent rules. So 2 to the x is equal to y to the 1/2. Okay, it says what is 32x? And I think the rest of the problem circled around over here. It says in terms of y. So it wants to know 32x in terms of y. Okay. Well, let's see if we can manipulate this just a little bit. All right, if I have to turn 2x into 32, that means I'm going to have to blow that up. Let me change colors. Blow that up by 5, because that would be the same as 2 to the 5th switching with x, right? And 2 to the 5th would change to that 32. So that's what I'm thinking here. Okay. See if we can do the same thing on this side. So if I blow this up by 5, now I have y to the 5 over 2. And that would give me the same as saying the square root of y to the 5th. So in terms of y, I would say we have our answer. What is 32x in terms of y? Our answer would be square root of y to the 5th. All right, that is the end of our notes for 10.3. If you have any questions or if you need to rewind and rewatch something, go ahead.